Hello everyone, welcome back to this lecture. In this lecture, I am going to discussing about very different thing, that is practical use case of decorator. We have seen there number of lecture I discuss about the functionality and many more about the decorator. In this lecture, I will dive more into practical use cases of decorators. And in previous lecture, I discussed about some built-in decorator, that is static method, class method, and property. These methods are frequently used and they play a crucial role in structuring your function. Let us understand the practical use case of decorator. As we know, decorator is just to help the developer to provide the extra functionality or superpower to the original function without modifying the original function. They play a crucial role in enhancing the power of a original function. Looking at these features, there are, I will talk about only few use case of decorator. There are many more use case of decorator. So first one is a logging. Logging in login, it is useful for a debugging and monitoring. Suppose you have a original function and you write a code for a decorator. That decorator has some logging functionality. That decorator you will use to decorate the original function, or that decorator having a logging capability. This capability pass to the original function, but that function become more beautiful in terms of logging for debugging and monitoring. That is the first use case people generally use for a logging. Second one is a timing function execution. When you build a application via Python, so you are concerned about the how much time it will take to execute, because if it is taking a less time, it become provide a more convenience to the client or to the user. But it takes a more time, it become ineffective. So we have to optimizing and making a efficient code so that it take a less time. To track this time, execution time of a code, for that we need some time function, or say in simple terms, we need time functionality that can be add to the decorate original function. This timing functionality we keep in the decorator, and this decorator will be used to decorate the original function to count or to know how much time it is taking to run the function. That is very important, use case of a decorator. It is very important for performance optimization, because we must know about how much time it is taking to execute the code. If it is taking a large, so we have to optimize the code to make it very less time to take to run. And third one is a access control and authentication. Suppose you made some application, and you want only a registered user will able to uh, go to that application, and non-registered user first have to register, then move to the application. To check this condition, for that we can add in the decorator, to add this functionality decorator to check if it is if it is a registered user or non-registered user. That can be add as a decorator in our original function, to make our function more beautiful and more modular and more Pythonic. This example I will take at the end of the lecture. I will write a code and I will explain each use case by writing a code. Fourth one is a memorization, catching the results. Okay, catching result means you have written a code and your code is doing a same thing again and again. They are recomputing the something. So you want this is running every time. Can we cache them? Can we store this result, and this result will be used when we run another call, another function? Can we use them? If it is if it is reusable, if we can store in a place, then we can retrieve and we can use them. It means in simple terms, I say uh, it the caching results or it store the result of a expansive function call. If you call a function multiple times, it will recompute same thing again and again. So you don't want to recompute again and again. So Python provide some built-in decorator that will help us to cache the recomputed value. So that is decorator is a LRU cache. Okay. So let's dive to the coding part, and I will write and try to explain the each use case of a decorator. Let's dive to the VS Code. Okay. So here I will write. First, I will create the new file. Here I will use case of deco.py. Then I will zoom in. Okay. So let's do for the logging for how logging work. Let's I create the first decorator log function. It will take a function, and I will create the wrapper function. It takes the arguments, and it will take a keyword arguments, and I will printing something like calling function, a calling function. Here I am just printing like func. It will func dot name. It will return the function name, the function we are trying to decorating with the argument. Okay, let's write thing arguments. Then we will store the result of the function. I copy pasting the arguments, and after that here I will write like printing func. Here again I am writing function name we are trying to retrieving, and here writing returned result, and I am returning the result. This is the I write a decorator function, and I will use to decorate the function. So first I will write like add x and y. Here I am trying to adding the two variable x and y. I want to decorate it. So log function. So let's run, and first I have to call them. I think you know how it work. So what happened? I again repeat. So what happened? This is our original function, add function, and this is decorator trying to decorating our add function. What happened? This function, it is called and it takes the add as a func. Then it will return the wrapper. Then wrapper called. After calling this function will called, we get some result and we get a result. That is the no it how it works. So you will see calling function. You will get the name. Okay, func is not defined. Okay, yeah. So here I'm getting some error. Yeah, see, name func is not defined. Line one. Okay, this is the function I write. Okay, name error. Name func is not defined. Okay, that is function I used. Let's run again. Yeah. Okay. So what happened here? As I say, this low function have required the argument as a function. To add function came here and it returned the wrapper. Wrapper means it did go here. In wrapper, we are printing calling function means I write here function dot name add with argument and it give the result. Result is stored because this function will return something and the 12. Okay, that thing is working. So 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 let's this is a part of logging. We are trying to getting the it no in add function we don't have any logging. We have not written any explicitly logging function, but in a low function this decorator can be used for a different function as well. We don't need to write same code again. That no we adhere to the dry principle of a coding. Okay, timing function and timing function execution. What happen? First, I will write the importing the time. Here I'm trying to calculating that how much time it taken by the code to run. So I create the timer and here function. Let's copy this same and let's change something. First, I have to measure time. So I have to write here start time time dot time and so we want to measure the time how much time it taken by the code to run. So I have to put this result in between. I write the and time and here time dot time, then I will print the like here I mentioned took and time minus start time dot for f. Dot for f I return to, only I want only up to a 4 decimal seconds to run. Okay, so let's write a code. First I define the like slow function and here let's I take a like I'm sleeping this system for a 2 second, not system this function because I don't have a code to very complex code to take a time to run. I will write return. I'm printing some like we have done work. Okay, I have to decorate this timer. So let's run. First, I have to call this. slow slow function. So let's run. Yeah, so let's run this. So you will get the time, how much time is taken by the code to run. The code we are trying to measure is this code. So you will see we have get the 2 second it taken to run this code. Okay, that is the use case of a decorator to measure the time, how much time is taken by the code or block of code to run. That is required for a deploying the system, deploying a code for a use case. So let's move to the another use case like access control or authentication. So I comment this one. Let's write another use case. Here, user try to authorize before allowing access to some functionality. It means we are trying to checking the user is valid or not. Okay, it is essential for a security. Like in payment system, we use this. Like I write the decorator admin and here is a function define wrapper user role if user role is not equal admin print. Here I'm printing some message access denied if it is not equal denied. Here I'm writing like admin only can get access of it. So let's so we are written something we don't want the function written below that. It is called. I will write the func and user role. Then I will call run wrapper. Okay. So when first it will check it is admin or not. If it not admin, it means it will deny it, and it is admin to call this function. Delete database. Just random function I'm taking. User role. Here I'm printing some like pass. I don't know what should I write, so I'm writing a pass. It do nothing. Okay. So right here I will write the require admin. I think it is right. Okay, I write some. Okay, let's call this function with some name. Let's I write let's write like I write the Himanshu. Himanshu want to access it. Let's run, but it is denied because I check. It is checking. This is the wrapper. It checking it is exist or not. Okay, it is. That's why it is giving error. Let's write the admin. So you will see and here okay it's here admin. Okay, I have to write here dot lower. Yeah, we should write always in capital. Okay, case sensitive. So here you will get it get access. Okay, that is user authentication. It is essential for a building application that required the security. Okay, the few people can only access. Okay, so let's move to the last use case. Not last, let's I run the code. I import the func tools allow cache define Fibonacci and if n okay and return something and return Fibonacci and -1. We are trying to writing a function uh, where where we I am writing in a writing function for a finding a Fibonacci series. So I'm writing Fibonacci minus n minus one and plus this is a recursion. If you know, if you don't know, don't worry. I will teach you in the upcoming lecture. First, I will cover the decorator, then I will cover the ops concept, inheritance, abstraction, encapsulation that are left. After that, I will cover some uh, miscellaneous topics. I write n minus two. Okay, don't just try to understand the how no how it works. I'm just printing Fibonacci. Okay, Fibonacci of like 30. If I first I will write 3. Let's say, so what happened in Fibonacci, it like 0, 1, it add the two previous element 0, 1, it must 1, 0, 1, 1. I write here first 0, 1, it become 1. It will add 2. Like if I write for a 4, so you will see we should get a 2. Okay, okay, 4 means here yeah, because in Python index start from a 0, 0, 1, 2, 3, 4. Okay, 0, 1, 2, 3, 4. If I write a 5, it means should be 5. Let's run again. Okay, so that is the no, we are trying to adding last two element to get a new element in a series. That is the Fibonacci. And if I write a like 30, it is a no nth number we are trying to getting from a series. So this is a 30, but it takes a lot of computation. It takes a lot of computation. To avoid this computation, I can avoid this computation. Suppose I calculate like 2, I calculate for 30, then I want to for a 100. So I can save some memory, I can save some speed, I can save some computation of to keeping the 30th uh, 30th Fibonacci series in a cache. That cache will be used to compute the 400. That is the effective way of using a some saving some memory and uh, speed up the program. Cache. Okay, here I am writing some some it takes max size none. So let's run see. Okay, so if you don't use this decorator LLU cache, so it takes like 100 seconds, yeah, more than that. But if you use the LLU cache, so it become very faster because because whatever result of a 30th Fibonacci series are you calculated earlier, it will be used again to calculate for a further like 100 Fibonacci series. So decorator are very useful. I train you by giving a for example, and for first is logging, second timing calculation, and third is for security reason admin authentication, and fourth one is a how you can use a cache to speed up the program. So decorator are so useful. You don't need to modify the original function, and you can apply same decorator to many function. You don't need to reuse. You don't need to write a decorator again and again. You can use same decorator for a very multiple function, and it make your code cleaner, more modular, and more Pythonic. I hope you understand this lecture. Thank you so much, everyone. See you in next lecture.